Okay, this video is being used in conjunction with the notes, solving systems of equations using substitution. So I did provide a worksheet or the notes with all the answers, but I figured I would take a couple of them and just kind of explain them through to make sure that you understand how to do the process. All right, so even though you see all the steps here, I'm going to kind of go through the kind of what I did so you can see. All right, so on this, basically what's happened is that we need to solve these, find the point of intersection given these two things, these two equations. And so what you have to do is you have to solve an equation for a letter so you can plug it into the other. So since problem equation number 2 is already solved for y, I put everywhere I see y in the first equation, I put this 7x minus 9. The reason why I do that is because I need one variable in order to solve it. So I need to get everything in terms of one letter. So the best thing I could do right now was to find x. So basically, I wrote the equation, the top one equation. So down here, I'm writing the same equation. But as I get to where I see y, instead of writing y, I write this piece instead. So basically, it kind of looks like we melded the two equations together. Anyway, I have so I wrote the rest of the equation. So the only part that changed was this piece right here, which is now x's instead of y's. And then I solve the equation like normal until I get to the answer, to half of it. And notice that's the x coordinate of the point of intersection. Now, if we were graphing, both these were y equals, and I graphed it, then this is going to be my ordered pair that ends up being the point of intersection. But how did I get this negative 2? Well, remember that this equation actually has a dual purpose. You can use it twice. You're using it to solve, but you're also using it so that when you take this 1 right here, you can put it back in over here and compute it. And that's what I wrote the math right here, just to make sure you saw what I did. And sure enough, when I put in the x of 1 into the equation that makes an expression that shows you what y is equal to, I get y is negative 2. So hopefully this is not new because you did have it in Algebra 2 somewhere. But I know if you were in Algebra 2 trig, you got it. I think we skipped it in Algebra 2. So regular Algebra 2, maybe not. I don't remember. Anyway, let's go on to the next problem. Let's see if I can do this. Next problem. All right, the next problem, the reason why I show this one, and this is number 6 in the notes, is because this happens to be where nothing is solved for a variable, and you look at the equations and you try to decide which is the easiest letter to solve for in either one of the equations. And in this case, I already have it boxed in, but in this case, x is the easiest one to solve to get by itself because there's no division. I don't have to worry about any division. I just have to get this 5y over to the other side, which I do with a plus 5y. Which makes this nothing, obviously, and I get x is equal to 4 plus 5y. So now I go up to the other equation. Never, ever, ever take the equation that you solve for and put it back into itself, because you'll always get all real numbers, and we don't want you to do that. So you're going to take that, and you're going to put it over in here. Okay, so sure enough, as I see the letter x, I'm going to substitute it with some sort of form of y right here, this 4 plus 5y. And sure enough, the first thing I write is the negative, and then there's that x right there. I just put the 4 plus 5y in its place, and I keep on writing. Distribute, do all the steps here, and then basically I get down to y is equal to negative 2. Remember, that's the second coordinate of your point of intersection. To get my first, again, I would take my negative 2 and plug it into this bad boy right over here. Okay, and once I do that, and I showed the math for you just in case. If you were to go and compute that, you're going to get x is negative 6. All right, the last two examples are special cases, and I want to make sure I touch that. This one is you solved for a letter, which is what I did up here. I plugged that in for the x in the second equation. I computed everything, and my y's dropped out. So what do? Well, if I get a statement that has no x's and no y's left in it, then I basically can't do the rest of the substitution process, so I have to make a decision. Well, whenever you get something that is false, that means there's no way to balance the equation, then you write no solution. Okay. On the next example, um, you've got the same deal. I go and I solve this for y equals, which is what this says right here. I plug it into the second equation, which is 18x minus 3 times, and again, y equaled something. So oh yeah, y equals right here. Put it in right there. When I clean it all up, notice the 18x's drop out. You're left with 60 equals 60. Now this is true. This is all true all the time. So you're going to have an infinite number of solutions. Not all real numbers, because not all numbers work. It's just certain ordered pairs will work, but there's so many of them that we can't keep track of all. Basically, what's happened is if you had arranged this into y equals mx plus b and arranged this one into y equals mx plus b, you'd end up having the same line. And so basically, you'd have lots and lots and lots of points of intersection. Basically, every point on the line. So that's it. So that's all it is in a nutshell, and I hope this helped out.